Hello, everyone. My name is Steve Johnson. I'm a specialist solutions architect at AWS, specializing in mobile and web applications. And today, during the webinar, we are going to talk about building distributed apps with Amplify DataStore. Some of the things we're going to cover today, we'll start by discussing what Amplify is. Even if you're familiar with AWS, you may not know what the Amplify product is. So we'll cover that, and specifically Amplify DataStore, what Amplify DataStore is and why we made it. Lastly, we're going to show you how to build a multi-user application using Amplify DataStore, and we'll close out with some discussion on use cases for DataStore, when to use it, what types of customer scenarios work really well with Amplify DataStore. So let's get started with AWS Amplify. Amplify is actually three things. It's a CLI, sometimes called the tool chain, which does things like code generation and helps you build your backend cloud stack. It's a big component of DataStore, as we'll see when we go through the demo. The second piece of Amplify are the client libraries. And these are open source libraries you can use in your clients, your web and mobile clients. And they've been received extremely well by the community. They started off as just a JavaScript library. We've added higher order components, UI components, specific libraries for different frameworks like Angular and Vue and React Native. And you can use these libraries independent of the other parts of Amplify. Lastly, we have a hosting service called the Amplify Console. And the Amplify Console is used to build, deploy, and host web applications. So we made all the parts of Amplify so they work extremely well together. You can build apps start to finish using these three components, or you can choose to use them independently. It's really up to you. So this slide shows the AWS mobile reference architecture. And more importantly, it shows where the Amplify components sit in a mobile or web architecture. So you could imagine if you were building a mobile or web application without Amplify, you might have an API layer provided by AppSync that talks to different data sources, and those data sources could be either in the cloud, in a VPC, or even external data sources. But if you built it that way, you would have to know a lot about AWS, right? You'd have to know individual services, you'd have to configure them individually, and plenty of customers do this, but we've had a lot of feedback from customers that say, you know what, I just want to build mobile and web applications. I want to focus on the client side. It would be nice if we had a much easier way to handle the back end. So we start with the Amplify libraries. And as I mentioned before, you can use these independently of the other parts. React and React Native apps work extremely well with this. And you can configure these libraries to work with existing resources in your backend. If you don't have existing resources or you want to generate some, you can use the Amplify CLI to create API, storage, machine learning, all sorts of different categories inside the Amplify toolchain you can create on your backend. And lastly, if you have a web application and you want to deploy it to the cloud, the CLI will automatically upload your projects to the Amplify console where it can be built, deployed, and hosted. So as you can see, if you're a mobile or web developer, you have the ability to build your app just using the Amplify tools instead of having to build a complete backend from scratch. So that's Amplify, right? What is Amplify DataStore? Amplify DataStore is one of the categories of Amplify, and it provides a model for dealing with distributed data that does not require you to write a lot of the code you normally would. for such an application. It uses what we call a local programming model. So you work with your data as if it was local data, and Amplify DataStore takes care of the hard things, right? Like offline scenarios, conflict resolution, making sure your data is consistent and concurrent. So why Amplify DataStore? If you've done this type of programming before, if you've built multi-client applications, you know that state is hard, right? Getting a consistent, accurate view of your data across your clients and across your back end is never easy. What DataStore will do for you is it will take care of offline behavior. It can detect your network state and start using data from its local cache. When you come back online again, it will resync to the cloud and update with any actions you've taken while you were offline. It takes care of versioning and conflict resolution. So let's say all your customers are offline for a few minutes and then come back online again. As all of those clients update, DataStore will actually orchestrate all of those changes and updates and make sure all of your clients have an accurate view of the data. So our goal for DataStore was to make this type of programming easy. And we did that by providing a local programming interface. What I mean by local is you just have basic CRUD operations and you don't worry about the things we just talked about. So let's look at how DataStore works. The developer's view of DataStore is very simple, as we discussed. You've got 4 basic operations on the DataStore object. You can save, query, and delete, and those take care of your basic CRUD operations. You also have a 4th operation called observe. Now, because DataStore is actually built on top of AppSync, which is AWS's managed GraphQL service, you can have real-time notifications of changes to your data. And those are actually done under the covers by GraphQL subscriptions. So let's say as a developer, you want to know when certain data types are changing, or even a certain line item of data is changing. You can subscribe to that change, and DataStore will automatically send you that data over a WebSocket. Of course, you don't have to worry about the WebSocket because the libraries abstract that away for you. But it gives you basic CRUD operations plus a pub/sub notification model. So this is a little more detailed view of what's going on, right? The developer still sees the DataStore API, but the libraries themselves and Amplify have 2 engines that it uses to coordinate all of this data. The first is the storage engine, which abstracts the API from local storage. You're actually free to use DataStore as a local data API if you want to. You don't have to connect it to the cloud. You can also plug in your own storage implementations using the storage engine. So it's pretty flexible that way. For our demonstration, we are going to be using the cloud, and we will have a multi-user app. So there's another engine called the sync engine. And its job is basically to take the client view of the data, which we call the model, translate that to GraphQL types and operations and send it to AppSync, and do the converse of that. Take the results from AppSync on the back end and convert it to the client data model. So what does the sync engine and storage engine take care of? It takes care of versioning, timestamps. It keeps the equivalent of a database journal on the back end that tracks all changes to the data, and also does intelligent caching. So all of these things are being done under the covers, and that provides us with our offline behavior, our conflict resolution, and our data consistency. So how do you get started developing with DataStore and Amplify? Well, the first thing you would do is go to the AWS website and install the Amplify CLI and read the documentation there. It's all available on GitHub. And once you've installed the Amplify CLI, you will take an app, and these apps can be JavaScript apps, native apps, and you're going to enable Amplify in the app by running a command called Amplify init. So the type of apps you can use with Amplify DataStore is shown here. As you can see, JavaScript is well supported, and we also support React Native, which is the framework we're going to be using for today's demo. We also have in preview Amplify libraries for iOS and Android, and those should be released fairly soon. So once you have your base application and you've initialized it as an Amplify app, the next thing you're going to do is define a data model. Now, the data model is the basis for how Amplify is going to generate all of the code and resources to make it work. And this is actually really great for a developer because you can focus on your data model and how it works and not worry about the plumbing and the logistics of how you need to tie it together. So let's take a look at the model definition for the demo we're going to be using today. We've got three basic data types. We've got products and a catalog, and the customer is going to be able to make orders for products, and each order is going to have line items. And of course, the line items are associated with products. So a couple things about the model definition here. If this looks like GraphQL, you're not wrong. We do our model definition using schema definition language from GraphQL. So that gives us a couple benefits here. We have the fields in these data types are typed with things like ID, string, and float. You can also have aggregate fields. For example, in the order type, we have line items, which is an array of line items. And we also have the option to tell Amplify if we want these fields to be required or not required. That's what the exclamation points are for these types. So once we've built this model, and the model is simply a text file, right? And we'll demonstrate how this works in a few minutes. Once the model is complete, you're going to generate resources. And those resources are generated by the Amplify CLI. We've already talked about Amplify init, which initializes your app. And DataStore, since it's built on top of AppSync, as we've discussed, you're going to configure DataStore through the API category. So we're going to add an API to our project. We're going to run the code gen command to build models from our schema that we just created. And then we're going to do an Amplify push to push this to the cloud. And the push does a couple things. The most important thing it does is it takes a CloudFormation template that was generated by Amplify and then deploys it to the cloud. And this is really great because Amplify, even though it does a lot of work for you, everything it does is transparent. So after you push a stack to the cloud, you can go into your console and see exactly what Amplify has done. You can go to the CloudFormation console and tear down the stack if you want to. So these are basically the four operations that generate your code and push it to the cloud. And lastly, you will write your client. So at this point, everything is ready for code. You just add some libraries to your client application. In this case, it's React Native. So when you write your client, you're going to need to import the Amplify libraries. On the left there, we're showing 3 of the libraries that we are using for the demo. The ones in blue are the core AWS Amplify libraries. Those are JavaScript libraries. And you can see they're segmented, so you can import just the elements of Amplify that you need and help reduce the footprint of your app. The green item there is a framework-specific library for React Native. Those contain high-order components specifically for that framework, in this case, React Native. It also contains UI components, which I'm going to demonstrate for you in a little bit. So the app in question today is going to be a coffee shop app. And if you've been following the AWS mobile blog, this is based on the same app from the offline reference architecture blog that came out a couple weeks ago. So what we're going to do is use the same app, and we're going to add multi-user capabilities to this. And by multi-user, we're going to include offline capability. We're going to include conflict detection and all the things we discussed, right? And my goal for this demo is to show you basically how easy it is to incorporate this into your applications. So I'm going to switch over to a terminal now, to our Amplify CLI, and get started with the application. Okay, so here we are at the terminal. I've already installed the Amplify CLI, and our first step is to create our React Native app. We're going to call it Coffee, and we're just going to make it a default new app. And this script is a React Native script. It's going to basically generate hello world for us in React Native. So we're going to let this process for a few minutes. Okay, our project is now set up, and the next thing we want to do is initialize this project. Make sure you're in the project directory, and then run the Amplify init command. Okay, we're going to call this a demo environment. We're using Visual Studio Code. Now, Amplify init automatically detects that this is a JavaScript project and can figure out that it's also a React Native project, which is nice. The rest of these options are defaults for React Native. So we are going to just hit return, and Amplify init now sets up some S3 buckets in the cloud and some credentials for us so we can start using it. We do want to use my default profile, which has all the permissions I need. That profile refers to an AWS command line prefile. As you can see here, it's setting up some roles and a bucket for us. Now, these resources are used by Amplify itself. These are not part of your application. It just sort of gives you the scaffolding for Amplify to do what it does. Okay, we've initialized the project, and now we are ready to move on to step 2, which is creating our schema. So let's go back a directory here, and we're going to write up our model schema. So we're going to define our model in the code editor right now, and I'm going to start with a base schema that contains the data types we talked about in the presentation. There's going to be an order, a line item for each order, and then a product type. So the way we tell Amplify how to treat these data types is using something called transforms. And the first transform we're going to use is the model transform. And not surprisingly, this tells Amplify we want these data types to be part of our model. So we're going to add that to all 3 types. And just by adding model, Amplify is going to build a backend for us, which includes a DynamoDB database and all the associated logic inside of AppSync in the resolvers. The next transform we're going to use is the connection transform. And this tells Amplify how these model types are related. So we have a relationship between orders and line items here. So I'm going to add a connection transform and give it a name that makes sense, something like order line items. And this is modeled as a 2-way connection. So I'm just going to take the same annotation and add it to the other side of that relationship, which is the order field in the line item type. Okay, so now we have a two-way relationship between order and line item. There's one other relationship we want to define here, and that is that each line item is associated with a product. So I go to the product field and I just add connection. And since it's only a one-way, it's only modeled as a one-way relationship, I don't have to give it a name. The third thing we want to do, and probably one of the most important things, is to add authorization rules for the operations associated with these objects. And we do that using the auth transform. Now, the auth transform takes arguments that include rules, and you can have more than one rule. You can have, in fact, it's an array of rules. You can have a rule set associated with a type. And for our purposes, we're going to start with something really simple and allow all operations by the owner of the data. So you may be asking, where's this owner coming from? When you add an auth transform such as this, Amplify will automatically generate an owner field on the back end. And all of the logic associated with those authorization rules will use that field. But if you want to use the owner field on the client, for example, if you want to show it in a UI, it's got to be in the client's view of the data, which is the model we're defining here. So let's say I want to add the owner to the UI, which is actually something we're going to do in a minute. All I have to do is go into the field definitions and add owner, which is conveniently there. So I added this specifically to the order field so we could use it on the client. Also added it on the line item definition as well. So now that we've finished our definition of the model, this is what we call a fully annotated schema. We can go over to the command line and move on to step 3, which is code generation. So we're going to go into the application directory, and we are going to configure DataStore through the API component. As I mentioned before, DataStore uses AppSync, so we are going to add an API to our project. We're going to use GraphQL for DataStore applications, give it an API name of coffee, and the authorization type is going to be Cognito user pools. So when we create this API, Amplify will also create a user pool for us. The default configuration will be fine for DataStore, and we want to log in using username, so we'll go ahead and select that. And no more advanced settings for the user pool. Now Amplify is going to ask us some questions about the API itself. I do want to make further configurations on the API for DataStore. I do not want additional auth types in this case, but I need to set conflict detection to yes. By adding conflict detection to our application, Amplify will create all the necessary resources for DataStore. Now, we do have some options around how Amplify handles our conflict resolution. We have optimistic concurrency, which is the simplest kind. We also have something called auto merge. And think of auto merge as sort of like a diff algorithm for objects. So if you have a hydration of data that different people have updated, instead of just clobbering one version with another, Amplify will go through field by field and make the correct adjustments to the data. If you want your own logic, you can also use a custom Lambda and write your own conflict resolution logic. But auto merge is a great choice, so we're going to pick that. And next, it asks us if we have an annotated GraphQL schema. We do, because we just wrote it. So now we're going to tell Amplify where it is. Okay. Now let's see what we have here. We have our Amplify status. And you can see we've added an API and an auth category. Next time we run push, it's going to create those. That's what the operation says. So before we do that, we want to make sure we generate the model for the client side. Everything we did with Amplify Add API was done for server-side configuration. Now we're going to actually build the models from our annotated schema. And we do that through the Amplify code gen command, which will generate models for us. And these models are JavaScript and TypeScript files that are used by the client-side Amplify libraries. Okay, now we have our models, we have our CloudFormation templates ready to go, and we can create our application in the cloud using Amplify push. Asks us if we're serious. We are. Right now we're being asked if we want to generate code for the newly created GraphQL API. In the cases where you're using DataStore, you can actually say no to this, because the code generation is going to be done as a result of you selecting auto merge and conflict resolution. So the Amplify push is complete. The CloudFormation template has been deployed. And now let's do another Amplify status, see where we are. Okay, it's been successfully updated. If we were to do push again, there would be no change. This is the status we want. It also tells us our GraphQL endpoint if we want to do any testing against the GraphQL endpoint. That's a nice feature. So now we move on to step 4, which is creating our client. I'm going to go up here. I have the code ready, and I'm just going to move basically the application, the assets, the package JSON, and other source code over to our project here. Okay, so let's go down to the coffee directory. Okay, let's take a look inside our code editor. So we're in the code editor right now, and we're going to go into our coffee project and take a look at the source code. So the first thing I want to show you is the base component for this React Native application. If you take a look at app.js, up at the top here, you can see we're importing a couple Amplify libraries. We're importing Amplify Core and then the Amplify Auth library, which is used for authentication, right? And these are compartmentalized. You only have to import the pieces of Amplify that you need for a given component. And if you take a look at the base component here, it uses a navigation container. And the navigation container allows you to have different components in sort of like a tabbed format where you can flip between them, all based on a single component. And each component in that container is under here in the source directory, under the components directory. And you can see here, there's going to be a catalog page where you can select items to order, a checkout page, an order page, which contains an order list, and then receipts, as well as a settings page. So this is the way the application is structured. I now want to show you the data store pieces of this application. So most of this is vanilla React Native, which looks a lot like React, not surprisingly. But let's take a look at those core API calls that the application is going to make to the DataStore API. And the first one I want to show you is query, which is in the catalog component. So if we take a look at the fetch products method, all we have to do is call DataStore query for a certain model type. And you remember from before, we created 3 data types. There's a product, there's an order, and there's order items. And you may be wondering, okay, where does this model come from? You know, we generated it. Where does it actually live? So if we take a look in the source directory here, you'll see there is a models directory there. And the models directory contains a JavaScript object. We're going to export an object here that contains our models. And it's based off of the schema we built. And there's actually a schema JavaScript file that was generated for us by the code generator. So all this data is sorted into the client, so we can now refer to these data types by name. So the next thing I want to show you is the save command in the DataStore API, which is on the checkout page. So when I go to the checkout source code, you can see this line of code. Every time I create a new order, I'm going to save an order object. And you can see here, I can declare the order inside the call. It's very simple. It's exactly the fields we defined in our schema, and it will be saved to the backend database. One of the other operations we haven't looked at yet is the observe operation. And observe, remember, is going to tell DataStore we want to be notified when something changes inside of the data model. So we're going to go to the orders page and take a look at this line. You can see here we have what we're calling a subscription during the refetch, and we're going to observe changes to the order data model. And this is important because when the user goes to the application and looks at the past orders, they need to be able to see the orders without doing a completely new fetch. The other thing that's great about this is when we put in the authentication piece, it will only fetch the orders that belong to us, which is super important. And the last thing I want to show you on the settings page is an operation called clear. Now, we don't really have a need to delete individual items in this application, at least not the way it's set up, but we do have the option to clear the local data inside of DataStore. And there's a button for that on the settings page, which is where this comes from. Okay, so now we've talked about the structure of the application. We've showed where the DataStore API calls are. And now what I want to do is show you how to add authentication and authorization to your Amplify app. Let's install our required packages so we can run our application and test it out. So what I did before, when I copied the code over, I also copied over the package.json file, and running yarn install is going to install those packages for us. Okay, our packages are up to date. And now we're going to use Expo to preview our application on the iOS simulator. Okay, let's open up our browser. If you haven't used Expo before, it is an application you can load on your mobile phones, and it provides a link between your development server and the app on your phone, so you can actually see in a WYSIWYG fashion what your application looks like. So we have Expo up and running, and I am going to run my application on an iOS simulator, which I have running in the background here. So here we have our coffee bar app. As you can see, we didn't have to log in to get there. So whatever orders I make in the application right now, anyone who uses this application could see my orders. They could see that I like to drink a lot of hot cider in the morning, and that's something I don't want people knowing, right? So we need to add some authentication to this application using Amplify. So let's do that. I'm going to go back over to the code editor, and I'm going to start with the base component, app.js. And I'm going to start by importing a component from the Amplify React Native library called with authentic. AWS Amplify React Native. Okay. With Authenticator is a function that wraps a component and automatically adds authentication to it. So just by doing this, I've made my app secure. So we're going to save that. And now we have the ability to log in to our application. Of course, if you can log into an application, you should also give people a way to log out. So inside the code editor, we are going to go to our source directory and take a look at the settings component, because that's where we are going to set up our logout functionality. So right now there's two buttons on the setting page. There's one to create products, and there's a second one to clear local storage. So we're going to repurpose that local storage button to also be our logout button. And to do that, we are going to first change the text on the button. And inside Clear DataStore, we're going to add the logout functionality. Okay, so there's two separate things we're doing here inside of this function. First, we're going to log out of the auth component, and then we're also going to clear the local data from the data store. And this is important because even though DataStore will use that owner authorization we defined before to only draw in data that belongs to the currently authenticated user, when we log out, all of that data is still in the local data store. So if someone else logs in and we don't clear it, they'll potentially see somebody else's data. So actually, let's do the data store clear first, which is already there. And then we're going to do the sign out using the auth component of Amplify. Okay, so now we have a logout button. It's going to call clear data store, which clears the local data, signs us out, and then navigates us over to the checkout page. I'm just going to save that. And there's probably one more thing we want to do just to make sure everything I told you is actually working the way I said it does. So we're going to take a look at the order list. We're going to look at the component there. And right now, when we look at a list of orders, there is going to be the time that the order was made, and then it's followed by an order ID. Now, the order ID isn't terribly useful for end users because that's just the identifier for the record inside DynamoDB. So we're going to swap that out with the owner field, so we can actually see who these orders belong to. So all we have to do is change that. We do have access to the owner because we added it to the model earlier. And now we're ready to go back to the terminal. So inside the terminal, we're going to kick off our application. by typing yarn start, which is kicking off Expo, which gives us our web interface here. We're going to run it on the iOS simulator and take a look at the changes we made, especially regarding authentication. So it's going to take a second to boot up. And you can see we have an authentication page here. And this is presented to us because our base component, app.js, is wrapped in the with authenticator function of Amplify. In addition to having a login page, it also gives you forgotten password functionality and also the ability to sign up new users. Now, this is a new Cognito user pool, and ordinarily I'd create a couple new users for the demo, but due to the miracle of editing and the fact that that's boring, I'm not going to show that to you. Just we have a couple users in the user pool, and I'll sign in using those. Another thing to mention about the authenticator component that Amplify gives you is it's not just a UI. The auth component actually monitors the status of the authentication in your app. So it knows if you have a currently logged in user, if they have credentials. It has the ability to pull those credentials from the cloud as well as renew those credentials using a refresh token. So the goal of Amplify in general is to make this sort of programming easier. And the auth component is a really good example of that. So what we're going to do is log in using a user and take a look at the changes we made to the code and how we're able to look at data that is specific to the user that's logged in. So we'll start out logging in with Steve. And we have a catalog page here that we're going to refresh with our items. And I'm going to create a new order here to have a black frap, energy panini, and a cupcake. I'm going to check out, and now I have an order created in the system. Let's go take a look at the orders page. And you can see all of the orders that are being shown here belong to Steve, the currently logged in user. That's the order.owner field that we added to the order list page. And just to show you how that works, we now have our logout button, which we're going to click, and then sign into another account called Rose. And create an order for Rose. We'll check out and now take a look at the orders. You'll see all of the orders here belong to Rose. Okay, so let's summarize what we did here. We took an existing application with no authorization and no multi-user capability. We created a model for DataStore that included authorization rules based on an owner. Amplify created all of the authorization code for us, created the back end, and even gave us UI components and other components inside our app that handles these things with a minimum of programming on our part. So Amplify did clearly most of the work during this demonstration. All we had to do was wrap the base app. We put in a logout button. We were sure to clear the local storage on logout, and everything else was taken care of for us. And hopefully this demo has shown you, all the hard work the Amplify team has put in to the libraries and to the CLI to make developing web and mobile applications as easy as possible. So now I'm going to go over to the presentation where we're going to talk about some of the use cases for Amplify and and the things our customers use Amplify for, in their production apps. And we're going to talk about use cases for DataStore, some of the things we've seen our customers use the product for, some things it's really well suited for and can really help you build impressive applications. So when you use the Amplify framework in DataStore, we've already talked about some things that make it an attractive solution. First, it's open source. You are able to look through the code, you're able to change the code, contribute to the code base. And that brings up the fact that Amplify has a really strong user community of both AWS and non-AWS developers. So if there's a feature you like or something you want to change or give more options to a certain implementation, feel free to contribute. The Amplify team is happy to welcome you guys into the community. We work with categories in Amplify. For example, we added API to our project. We did not add AppSync. That gives us a lot of flexibility down the road and the ability to create different plugins for certain categories. It's declarative. As we saw in the case of the authentication, you have the ability to declare your security rules and have Amplify build those for you. And if there's anything Amplify doesn't do for you, right, in its existing implementation, and you don't or can't contribute code to the project, Amplify is built with escape hatches where you can use it alongside AWS APIs and SDKs to implement the features you need. Okay, so these are a list of questions we ask to our customers when they're considering using DataStore. First one is, does it require complex state management? And that question is usually yes. If you have a multi-user app, especially if it's an app that's going to the public, right? You're going to put it up on the App Store, and you can have potentially dozens or millions of users. You're going to want state management in that case, especially if those users are sharing state. And that could be anything from a stock market application to just like a leaderboard on a mobile game. And the things you will get from this state management is the offline behavior, which is one of our most popular requests. Mobile, as you know, is an environment where you may not have reliable network. And Amplify is able to detect your network state and switch the context of the app automatically from online to offline mode. And when it goes to online mode again, it will resync to the back end and give you consistent state. The next big question is whether or not you use DynamoDB as your data source. And when I say as your data source, I mean the data that is going to be shared, the data that is going to be version controlled. In short, the data that DataStore will be working with needs to be on DynamoDB, right? So when you generate all of these resources on the back end, you're generating a DynamoDB database, a fairly sophisticated one, but it is a good thing to know before you go in, right? If you have a JavaScript-based client, which includes React Native, you're in good shape. As I mentioned before, we have preview versions of iOS and Android libraries, which are going to be released very soon. So we're really excited about that, and we're hoping a lot more folks will get a chance to try it out with the new libraries. So some of the use cases we saw, and one of the big requests for something like DataStore came from customers that have remote field operations. And this is why offline capability is such a big part of DataStore. We have customers that have field techs that may sync data to the cloud or their systems early in the morning, and they may be offline all day for 8 to 12 hours. And when they come back in, they'll need to resync their data and have it be consistent. So DataStore does a good job of keeping a local cache of that data for when you're offline, and also preserving all the operations that are done with your application while you're offline. Another application similar is retail. If you're doing real-time inventory or price changes, if you have a team of people doing inventory, you want to be able to do conflict resolution. Let's say there's 2 people in the warehouse and they're counting the same thing, but they're not next to each other, right? Then maybe your warehouse has the same thing in 2 different places. You want an accurate number, right? And you have the ability to do custom conflict resolution to keep your data consistent and accurate. Another thing is the real-time notifications are useful for price changes, right? If you make a change to a price in a catalog, that price should be reflected immediately through the client. We also have dynamic data scenarios where things are changing all the time. Once again, if prices on stocks changes, obviously you want to be able to notify it as soon as possible. If you're running an auction site doing bidding or certain types of games, right? In fact, a lot of competitive games are shared state games, so DataStore is useful for those. And lastly, if you do have custom conflict resolution scenarios, you can write a Lambda function and have DataStore implement your logic for your application. Okay, so what we've learned today, how DataStore fits into Amplify and AWS. We showed you how to build a multi-user application using Amplify DataStore. And lastly, when to use DataStore in your applications. So that concludes the webcast for today. My name is Steve Johnson. You can reach out to us. GitHub is a great place to interact with the Amplify community and DataStore in particular. You can request features, you can contribute pull requests, and just get involved in a really, really exciting development environment. And I hope this was useful to you, and I hope you get a chance to use it for yourself and find out what makes it special.